Hi, welcome to Real Learning Center. Today we are going to start a new topic called kinematics and graphs. So what is this kinematics? Kinematics is all about basically trying to understand the movement or the motion of bodies, okay, without actually really caring about the force, etc. So how do they move? Okay, what are the terrains? So those are the things that what is acceleration of the body? How do we compute? All these are called kinematics. And graphs are inherently most important tools to describe kinematics. So today we are going to basically start the first session of this, where we will go back to the basics of how to plot the graphs of any given equations. So let's understand what is meant by these graphs and how do we plot the graphs. So let's start with quite a simple thing, which is what probably we have learned at early when we started learning graphs. Let's go back to that basics a little bit. Okay, what I am having here is a tabular column which actually talks about x and y values. Okay, and they are not just random. Okay, this is given a set of x values. What are the corresponding y values? That is what I am talking about. That means if x is equal to 0, y happens to be 1, and if x is equal to 1, y happens to be 3, like that. Okay, so now the thing is that given such set of values of x and y, pairs of x and y, 0, 1 is one pair, 1, 3 is another pair, 2, 5 is another pair, minus 1 is another pair. So how do we actually plot them on the graph? So we have taken a graph here, a graph sheet. Okay, so in which we have basically have many equal sized perpendicular and parallel lines, which we call graph, and we have an x-axis horizontal and a y-axis which is vertical. So that's what we have taken. It is not necessary that x-axis is always horizontal and y-axis is always vertical. There is nothing like that. Okay, so it is just a convention that we take x-axis horizontal and y-axis vertical. We may take different things like time axis horizontal and something else, velocity axis vertical. So like that we can take many different things as the axis of our graph. Okay. So how do we start plotting? When we say, we always take the first set, let us say 0, 1 and 1, that pair, x is equal to 0, y is equal to 1. So we are going to plot it at a point here where x is equal to 0, means from the center I have travelled 0 distance to the right. 0 distance to the right means I did travel. I was at the center. Okay, and I have travelled to 1 distance towards upside, vertical. So that 1 distance is shown here. So I travelled 0 right and 1 up, and there I have put 1 cross. That is what is basically my first point. So now let's go to the second point. Second point is 1, 3. You can see I have travelled 1 distance to the right and then 3 distance up. So I have put a into there. So that is basically 1, 3. And then we go to 2, 5. What is 2, 5? I have travelled 2 distance to the right and then 5 distance up. So 1, 2, 3, 4, 5. I have travelled up to 5 up. So now minus 1. So whenever we talk about minus, okay, to the right side, in the x-axis, right side is plus and left side is minus. Okay, from that middle point, what we call origin, from there. Okay, and for y-axis, upside is going upwards is positive and going downwards is negative. So we will see minus 1 means you have to go left side, and then minus 1 again going downwards. So we are going to plot that. So we have got actually now 4 points here. After getting 4 points, okay, I want to basically, since these four points are related in some way, that's what has been told to us. So let's join these points. Okay, so when we join these points, we actually get a nice straight line. You can see. So now this straight line, okay, has basically has told us that these points lie, whatever point you are relating from x to y, they are all lying on this kind of a straight line. Till now we don't have an exception on that. Everything is lying on this straight line. So we are going to ask a question, okay, saying that is there some pattern in these values of x and y? Okay, when I give 0, I got 1. When I go have x is equal to 1, I got y is equal to 3. So are these numbers in some way related to each other in some kind of a relationship? Think about it. So if you think a little bit more, it's like a puzzle, think about it, and you will come to know that there is some relationship, and that relationship is that if you actually double the x, okay, add 1 to it, you will get y. Okay, let's, for example, first one, add double 0 and add 1 to it, so you get 1. Second one, you see, you take 1 and double it, you get 2, add 1 to that, you will get 3. Okay, so similarly, last one you see, minus 1, you double minus 1, you get minus 2. Okay, so then what will have, add 1 to it, add plus 1 to the minus 2, you will get minus 1. So that is how you basically got some relationship between these points, and we can actually express that relationship as some kind of a mathematical equation. We call it as y is equal to 2x plus 1. That is the equation. Y is equal to 2x plus 1. That's what we are saying here. 2 into x means double the x plus 1. That's all. 2x plus 1. Now, this equation, and using this equation, we can actually find out the value of y for different values of x. Like for example, we can say if x is equal to 2, x is equal to minus 2, for example, we'll take minus 2. What will happen? Minus 2 into 2 is minus 4 plus 1, which is basically minus 3. So you got y is equal to minus 3, and you can see in the picture also in the graph, for minus 2, go down, you will see it is meeting at minus 2, minus 3 point. Okay, and that point is basically shown here, you can see. So now, once you see that this graph has some kind of a relationship with this equation, so we will say this graph, the graph and a line basically is equivalent to this equation. So the equation and the graph are both equivalent. They are saying the same thing. Okay, so that is why we say that graph and equation are like two languages in physics. Whenever we talk about an equation, we have a graph also in mind, and whenever we talk about a graph, we have an equation in mind. So they are actually two languages saying the same thing. So to become good in physics, the first important thing is to basically make sure that you are able to relate them very well. Whenever somebody talks about an equation, can you imagine the graph of it, and vice versa. Okay, so that is why we started with plotting a graph. So this equation is basically equivalent to this line. Now let's see. Now if you take, for example, an equation, so we actually took a line and came to an equation. Now we are going to take an equation and go towards a line. How do I do that? I'm going to basically have an equation y is equal to 0.5x minus 1. I keep giving values for x and compute the value of y. So if I give x is equal to 0, what do I get? I get 0 into 0.5 plus 1. So it is 1, minus 1, it is minus 1. Okay. So if I give x is equal to 0, you get y to be minus 1. So similarly, if I give x is equal to 1, you get y to be minus 0.5, because minus 1 plus 0.5 is minus 0.5. Similarly, if you give x is equal to 2, you get 2 into 0.5 is 1, 1 minus 1 is 0, y value is 0. So like that you can give values. If you give minus 2, you will get minus 2, you can check it. So you can keep giving any number of values. Now once you give those values and get back these points, x and y pairs, so we can actually plot them. 0 and minus 1 is our first point. From 0 we go down to minus 1, that is our first point, you can see that one. Second point is 1 minus 0.5. So we go 1 to the right and minus 0.5 come back 0.5 times to the half. 0.5 means half the distance we came back. So 2 and 0. So 2 you go to the right and 0 up, so which is stay there. That is 2 and 0. Then minus 2 and minus 2, you can see come back, go down, minus 2 and minus 2. Now you can actually plot a line joining all these things, and now you can very clearly say that this line is equivalent to this equation. So, equation and line, this line are equivalent. Okay, so, we took actually an equation and we plotted a line, a graph. Okay. So, this is how we can take an equation and plot a graph, or look at a graph and get an equation out of it. Okay. So, they are very related to each other. This is actually, this line is basically a straight line. You can see it's a very nice straight line. This is a straight line. Okay. In the graph, what graph is this? This is a straight line graph. Similarly, this one is actually a straight line equation. Because it represents a straight line, this equation is called as a straight line equation, or a line equation, or a linear equation is what we can call. Linear equation of x and y. Okay. This is a line equation, this is a real line. Okay. So, these two things are related, line equation and line. Now, we will see some properties of this equation, what will happen. So, I am going to take y is equal to 0.5x minus 1. So, we already know how to plot that and we plotted it here. This is how it looked. I have not put the points here, but when you plot it, you will get it this way. Just previous one is the same thing. Now, if I try to plot something called as y is equal to 0.5x plus 2, how does it look? So, I will suggest you basically to pause here and try yourself to plot it if you already don't know about it. Okay. So, give values for x and find the values for y. And once you do that and you join all of them, you are actually going to get a line like this. Okay, and this line you can see, okay, is parallel to this line, similar, but it's slightly above. Okay. Similarly, if you take, for example, y is equal to 0.5x minus 3, how does it look if you plot it? Okay, it also looks actually parallel to this and down there. Okay, there is some relationship between these lines. If you carefully watch, all of them are, we are starting with 0.5x, 0.5x, 0.5x. So, the white line is plus 2, the yellow line is minus 1 and the blue line is minus 3 in the second part of the equation. So, that has somehow made these lines go up and down. So, how did that happen? What is these values? What are these values? What are they related to? If you see, okay, this minus 1 actually is a place where it cuts the y-axis. You can see that minus 1 is where it cuts the y-axis, the yellow one. And the white one, you see, it cuts the y-axis at 2. That is why there is a plus 2 there. And minus 3, you see, it cuts the y-axis at minus 3. That is why the minus 3 is there. So, it clearly tells us that whenever we see a number here, plus something, that something is where it cuts the y-axis. So, interesting observation, isn't it? So, we call this as y-intercept. Okay, this because it intercepts, the line intercepts the y-axis at this point. And we generally give a letter C to that. Okay, it is denoted by a letter C. So, we have now understood actually, if you have everything else same and only the last number is changing, then those lines are going to be parallel. Okay, and they are going to cut the axis at the y-intercept point. So, now let us see the other constant, which is 0.5. Okay, how is that going to behave? So, we start again with y is equal to 0.5x minus 1. Now, I am going to basically change that one. Okay, so I am going to call this 0.1x minus 1, I mean x minus 1. So, how does that look like? If you again go and plot this carefully, so you can see that it looks somewhat like this, the white line. Okay, so it actually cuts at the same point as the first one, and it so happens that they are not parallel. So, it has basically, the steepness has changed a little bit. The first line was little lesser steep and this one is slightly more. Okay. So, now we take the other one, the next one, which is y is equal to minus 2x minus 1. Y is equal to minus 2x minus 1 means I have actually put the coefficient of x. Now, whatever I am writing by the side of x is called coefficient of x, which is minus 2. Okay. So, and hence when you plot that, it actually looks something like this going down. So, what is happening here? We have seen that the minus 1 actually is the intercept and that remains same. It is cutting the actually y-axis exactly at the minus 1 point. Okay. However, the coefficient of x Coefficient of x means something that we write by the left side of x. That coefficient of x is 1 in the white, and yellow it is minus is 0.5, and blue is minus 2. So how are they actually related to the line itself? What of the line yellow is 0.5? That question, if we ask, it is little trickier than that, the first one. So let us see what happens. What I am going to do is I am going to basically try to find out for the yellow line 0.5, what is it for that line. Okay. So if you actually take one small triangle, okay, a right angle triangle, okay, like this, anywhere on that line, and where the hypotenuse is actually aligned with the triangle, such a right angle triangle we are going to take. Okay. This is vertical and this is horizontal. And what I am going to do is I am going to measure. I just pull it out that side a little bit, and I am going to measure what is the height and what is the base. Okay. You get that is what is the horizontal distance and what is the vertical distance on that. So we found out that one of them is 1, other one is 2. So and I divide it, 1 divided by 2. We call small change in y divided by small change in x. So which is called as delta y by delta x. Don't have to worry about that. It is the y part distance and the x part distance we divide. So 1 divided by 2, you get 0.5, and we'll assume that that is our 0.5. Okay, that is how we got the 0.5. There is some relationship between them. Now let us try with the other one also. Y is equal to 1x minus 1. So the next one. So next one, what happens is you can see very clearly that we can actually draw some kind of a triangle like this. So this triangle, again we have kept the hypotenuse and we have drawn a triangle. Now in this triangle, if I keep it aside and just see what it is actually 1 on the vertical side and 1 on the horizontal side. So 1 by 1 I get plus 1. Okay. So the last one is a little more trickier. Okay, that is minus 2. So let us see. So when you actually draw the line like this, now for the blue one, I am going to take it like this. So this is I always go right first and then down. Okay, right first and up like that. Okay, so this x we always go first to make this triangle. Okay. Now this triangle is is having what is the x direction and what is the y direction. Y direction is downwards here. If you carefully watch it, actually if you take it and see, x direction is just 1 and y direction is somewhere around it is 2. Okay. But y direction is going downwards, and we call it as minus 2. So this is 1 and minus 2. So minus 2 divided by 1 is minus 2. So this is giving us minus 2. This is what is the thing that we have. So if you carefully watch this, what is this signifying? So whenever these numbers, now what we call, which is by the side of the x, coefficient of x, we call that number as slope, and we denote it by a letter m. Okay. What is this slope? Why do we call it a slope? So slope high means it is steeper. Slope low means it is less steep. When it is horizontal, slope 0. When it is a down like this, slope negative. Okay, negative slope, 0 slope, and more slope, more and more slope, steepness. And we can calculate it by basically how much is this and how much is this. Y side and x side we divide. So we call it as dy by dx. That is the slope. Okay. So the slope signifies how much slant the line is. Okay. And the intercept signifies basically where it cuts the y-axis. Now, if we combine these two information, we have an equation of a line, and we call it as a generic equation of a line. And you have a slope m and you have an intercept c. This is the slope and c is the intercept. So if you take some examples and see actually how they look like. For example, if you take an equation called y is equal to x plus 1 and join it, you can clearly see how do we draw it. We take basically 1 as the intercept. We know 1 as the intercept. Okay, and after taking 1 as the intercept, now I want to get a slope of 2. For that, y is 2 and x is 1. Like that I have to draw a picture. at that point. At that point I draw 1 and 2. And after doing that, I am going to basically draw my line on the hypotenuse. And that is our line y is equal to 2x plus 1. And then you can take one more line and see how it works. Y is equal to minus 3x. Y is equal to minus 3x comes as plus 0. You can call it as plus 0 because y intercept is 0 here. So I will take basically a point at 0. So if you take point at 0, first point, and then take minus 3 as the slope, that means I will go 1 like this and minus 3 downwards. So that is my triangle, and on that right angle triangle I am going to draw on the hypotenuse, draw the line like this. So that is the line for the y is equal to minus 2x, now minus 3x. So we can also draw lines, for example, for y is equal to some fraction like this, 3 by 2x minus 2. So the minus 2 is our y intercept, that means it cuts the y axis at minus 2. So I will take my point there at minus 2. After taking the point at minus 2, what I will do? I will actually create a 3 by 2 kind of a 3 by 2 kind of a triangle. Okay, how do I do that? At that point, see, 2 on the right side, 3 on the up, 3 by 2, and that one hypotenuse I am going to basically join and make a line. So that is our y is equal to 3 by 2x minus 2. So this is how, given an equation, very quickly you can draw the line without actually going to plot in terms of giving each and x and y values and doing it. So looking at an equation, you can now imagine what could be the line. Okay, so that is the basic skill I want you to have. So before going into the kinematics. Now, is it always only a straight line? Can there be equations which may not be really straight line? That we can see. For example, if we see 0.5x square, y is equal to 0.5x square. Can we plot that? We can. We can give values to x and see what happens to y. Let's say if x is equal to 0, so y also will be equal to 0. If x is equal to 1, so 1 square into 0.5 is 0.5. So it is y is equal to 0.5. So what about x is equal to 2? 2 square is 4, 4 into 0.5 is 2. So y is equal to 2. So what about minus 1? Minus 1 square actually is plus 1 only. Plus 1 into 0.5 is again 0.5, plus 0.5. Even if I give minus 2, you get actually minus 2 square is 4 and 4 into 0.5 is 2. So this is again a positive number. And we can actually now start putting this 0, 0 and then 1, 0.5, 1 you go to the right and 0.5 up, then 2, 2, and then you go to minus 1 and 0.5 up only, minus 2 and plus 2 up only. So you get points like this. These are not part of a straight line. You cannot join all these 4, 5 points using a straight line. Instead, we can join using some kind of a curve. So with this curve, we call it as parabola. Okay, this is a parabola. So you can have a square term whenever you have y is equal to x square, kind of a square term, 0.5x square plus something, whatever. So you are going to basically get a curve, not a straight line. So please keep that in mind. In this case, it is a parabola. Now, what I would like you to do is try it out is some other kinds of equations and see whether you can plot and look at how they look at how you can see them. So for example, I can actually ask you to try y is equal to x square plus 1. Take a graph sheet and try it out and see how it looks like. This plus 1, where does it go? So please get an idea of how it works. And then you can actually have y is equal to 0.2 x cube. It's a x cube kind of a equation. Okay, and see whether how does it look like. X square kind of a equation is like a parabola. X cube, how does it look like? Remember that for minus 1 cube is not minus 2 cube is minus 8. So remember that and try it out. So these are the few things that you can try out and get an idea of how to plot graphs as equations. Okay, so till now in this session we have actually learned how to plot graphs of certain equations and how they are related to each other, and then also having some properties of lines we have learned, what is slope, what is intercept, all these things we learned. Looking at a line equation, how to say what kind of a line is this, what is slope, all that we have learned. And we got a little bit idea of how a parabola looks, square term is there, what will happen, all that. Now we are going to use all that in the next coming session to see how we can use that in kinematics, where we have displacement and we have velocities, and can we plot graphs after that, and when we plot those graphs, what is the advantage. So these are the things we are going to study in the next session. Thank you.